Mars has long held a place in our collective hearts thanks to its position as one of our closest neighbors. It's a fascinating world, and sci-fi writers and scientists alike have long pondered its potential as a home for alien life. Our search for answers has caused us to explore Mars' surface with rovers and orbiters, which have taken incredible images in pristine 4K resolution. Mars has a rugged beauty, a reddish hue that captures our imagination, and awe-inspiring features and landmarks to explore. What would it be like to walk on Mars' surface? What would we see? What is there to know about the red planet? I'm Alex Wakulgan, and you're watching Astrom. Come and see some of the captivating 4K images of the planet NASA and plenty of space agencies around the world are racing to get to as we explore some of the most incredible sides of Mars that you may not have seen before. To begin with, for an alien planet, Mars is not as foreign to us as you might think. Earth and Mars share a lot of similarities, one being the length of day. The solar day on Mars is only slightly longer than it is on Earth, 24 hours, 39 minutes and 35 seconds. Its year is slightly longer than ours, 88 Earth years, or 1 year, 320 days and 82 hours, but that's to be expected for a planet that's further from the Sun, and so has a larger orbit. Of all the planets in the solar system, the seasons of Mars are the most Earth-like, due to the similar tilts of the two planets' rotational axes, 23.5 degrees on Earth and 25 degrees on Mars. So, what does that imply? It means Mars has summers and winters, just like Earth does. These temperatures in the different seasons can vary quite a lot, and different locations can widen the range even further. Temperatures can be as low as 143 at the polar winter caps to as high as 35 in the equatorial summer. It has polar caps, just like we do. During each pole's winter, the pole lies in continuous darkness just like on Earth. However, unlike on Earth, the temperature gets so cold that the atmosphere there freezes into slabs of colonize ice, which collects on the surface of the permanent polar caps there. These caps themselves are not primarily made of colonize, but instead are made up of mostly water ice. The ice at the poles waxes and wanes. In this short video you can actually see the differences of the size of the polar cap, from the cap's winter to the cap's summer. One thing I love about Mars are these strange spiral patterns in the ice. Both of the poles show signs of these beautiful spirals, which scientists believe are a result of the Coriolis effect. The colonize at the poles does not remain there forever. As the colonize ice on the poles sublimes, it has an effect on another aspect of the planet, its winds. Sublimation of dry ice can create enormous wind speeds of up to 400, which can have a real impact on the dust strewn across Mars' surface, which we'll explore in more detail later. While Mars and Earth have their similarities, there are plenty of differences too. Mars is smaller than Earth, 6,779 in diameter, 12,742, and is also much less dense. This means the gravitational pull at the surface is much weaker than that on Earth. To get a feel of the impact of this reduced gravity, allow me to demonstrate with an example, using a rather handsome model. Watch as I drop a ball, with the time adjusted between the two videos to mimic the gravitational conditions between the two planets, Earth on the left and Mars on the right. As you can see, the ball does fall slower on Mars than it does on Earth. This is because Mars' gravitational pull is 62 lower than what we feel here. If you weighed 100 kg on Earth, you would only weigh 38 kg on Mars. Curiously, this is almost the same gravity as you'd experience on Mercury, even though that planet is smaller than Mars, with a diameter of only 4,879. Mars' gravity is only stronger by 1, and which just goes to show how much denser Mercury is by comparison. This allows for some truly amazing geological features, like this one, Olympus Mons, which is the tallest volcano and second tallest mountain in the solar system, only being beaten out by Resolvia Peak on the Vesta asteroid. The fact that it's not the tallest mountain, to me, is a bit of a cheat, as Resolvia has the added advantage of being in the center of a large crater, and measurements of its height tend to start from the bottom of that crater. Regardless, Olympus Mons stands 3 times as tall as Mount Everest's high point above sea level. Whereas Everest is very jagged and steep, the edifice of Olympus Mons is over 600 kilometers wide. It rises to the equivalent of 22 kilometers above sea level, which would be impossible on Earth, as Earth's gravity would pull it down. The only reason a structure like this is standing on Mars is because its gravity is reasonably weak. Olympus Mons is a shield volcano, and thus has a very low profile. The average slope is only 5 degrees, which means if you were to stand on the top, you wouldn't be able to see the entire mountain, due to the curvature of the planet. Olympus Mons can easily be seen from space. If we look at the topographic map, you can see it quite clearly. To me, it really does look like a giant pimple on the side of the planet. The center of the volcano has some collapsed craters, as you can see, and the outline of the volcano is this giant cliff face, which is up to 8 kilometers high. Another impressive feature of Mars stretches across the side of the planet like a giant scar. It's called Valles Marineris, and every time I look at it I can't help but be amazed by the sheer scale of it. This giant canyon is 3 times the length of Earth's Grand Canyon, and 4 times as deep. But when you look at the planet Mars, one of its most recognizable features is its color. Why is the surface of Mars so red? It all comes down to the large quantities of iron in Mars' surface. Over time, these minerals have reacted with oxygen to create iron oxide, or to put it another way, the planet has slowly rusted, just as iron does here on Earth in certain conditions. This explains the ground and rock's reddish-brown hue, as you can see in these photos taken by the various NASA rovers on Mars over the years. Images like these really help you feel like you're there on the planet's surface, in a level of resolution and clarity that would have been an impossible pipe dream for astronomers only a century ago. Thanks to missions like Viking 1 and 2, Spirit, Opportunity and Perseverance, we can see Mars' arid vistas as if they were right before us. Now, after looking at some of these pictures, you might be tempted to think that the red planet is a dead planet, but actually that's far from the case. Mars is very active, and there's lots of things happening on its surface. For example, have a look at this avalanche which happened in 2008 as an orbiter was going past. What was caught on camera was very surprising. Scientists could see a lot of dust had been kicked up by the fallen dirt. What you're looking at here are some dunes which are up to 700 meters tall, and this picture is about 4 miles wide, so you can see that this dust cloud is not exactly small. And here, take a look at this. Did you know that there are spire colonies on Mars? Arachnophobes. Don't worry, these creepy crawly shapes might be 45 and to wipe them across, but they are not truly spiders. Instead, they're carbon dioxide ice that has been warmed up by spring sunshine. Ice beneath the surface is warmed by sunlight and reverts back into its gaseous form, which then bursts through ice up to 1 meter thick on its way back to the Martian atmosphere. This eruption of gas explodes upward in a large geyser and takes dark material with it, scattering the material around in spire-like patterns. These images were taken by the Isaac Summers Trace Gas Orbiter just recently, as it flew over Mars in early 2024. Another example is this dune, photographed many times over the course of a year, and you can see that it does change quite a lot. There are ridges which become more apparent as the dust gets worn away. And I've shown a number of pictures of fresh impact craters so far, where you can see the dust has been kicked up by the impact. This one is particularly interesting, because after the impact, water ice in the ground melted, and you can see the trail as it flowed away from the impact crater. The colors there are just to show depth, they're not true colors. Mars' surface is awe-inspiring to look at, but this is sometimes harder to do than you might think, as Mars is home to huge dust storms. When fast winds pass over the surface, they pick up a lot of the loose dust on the ground, creating huge walls which can pass over the whole planet. It's sometimes hard to imagine the scale of the phenomena. These storms can very easily be seen from space. Have a look at this dust storm which was captured in 2012, and then only a week later you can see the difference since it died down. And on this photo, if you look at the North Pole, you'll see the storm, which has passed over the top. Global dust storms are unlike anything we ever experience here on Earth, and they're so fascinating I've done a whole video on them, which you can watch here. What do you think caused these patterns on the surface of Mars? Amazingly, they're caused by dust devils. These mini tornadoes are surprisingly common on Mars and have been photographed many times. Here we can see some from the orbiter's point of view. It's estimated that this plume is over 800 meters high and about 30 meters thick. And the shadow of this dust devil is about 2 kilometers across. And from the rover's perspective, we're actually fortunate enough to have a film of dust devils going past. You might think that with all the atmospheric phenomena we've just discussed that Mars has an atmosphere that's comparable to that on Earth. This is not the case at all. We are 38,000 feet in the air right now above ground level, and the air here is very, very thin. If I was to go out of the bay right now, not only would I fall to my death, but I would also struggle to breathe along the way. Now Mars is a bit like this, except even worse. If I were to actually get the same sort of atmosphere pressure as Mars, it'd need to go up 120,000 feet into the Earth's atmosphere to get a similar sort of level. Breathing issue isn't helped either by the fact that 96% of the atmosphere is carbon dioxide. So if you did want to visit Mars, you'd have to wear a pressure suit. Thankfully though, that doesn't stop Mars from having some absolutely beautiful sunsets, some of which have actually been captured by the rovers on Mars. The low atmospheric pressure on Mars wasn't always that way. The presence of dry riverbeds proves that Mars' atmosphere was once thick enough to retain the heat and pressure necessary for liquid water to flow. So, where did that atmosphere go? Scientists believe that Mars' magnetosphere, or lack of one, is to blame. Scientists believe that Mars lost its magnetosphere 4 billion years ago, which allowed solar winds to strip away atoms from the outer atmosphere for all that time. Some orbiters of Mars have actually detected these ionized atmospheric particles trailing off into space behind Mars. One of the last things the FI want to focus on today is Mars' moons. Mars has 2 known moons, Phobos and Deimos, which are small and irregularly shaped. Compared to our own moon, they're very small. If you were to look up in the sky on Mars, this is about how big they would be in comparison to what the moon looks like in our sky. While Phobos is the biggest of Mars' moons, even here its apparent size is a little misleading, as Phobos is actually a lot closer to Mars than Earth's moon is to Earth. The moon is 384,400 from